6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. And it has cleared the tower.
Prepare yourself for a world of science. This is
Welcome, everybody. It is another episode of the Science Nights. I'm Conley here, your host, and we got the Knights assembled, Dr. Sean Graham, Dr. Anirban Bhattacharjee, and paleontologist extraordinaire, Dr. Thomas Shiller in the house. And we got quite a lot of questions that they are actually going to answer. They're going to talk all science today. It's all science, and it's all your questions. And we're going to get right to it. Why don't we get right to it, huh? Okay, cool. So, we're going to start this show off with a very special listener. His name's John Harlow. He's on the line right now, calling in. Are you at Marfa?
No, I'm here in Alpine.
Oh, here in Alpine. Great. Awesome.
Yeah.
Okay, well, John, why don't you just let me know what your question is? And we have all three of the Science Nights listening in right now just to answer your question.
Okay. Well, my question is a NASA question. Even though the NASA's been, the budget's been cut for quite a few years now, do you think that someday the level of coverage on TV, whether cable or local news, will get to the anticipation like it once was, like with the, you know how like there was always a big anticipation for a shuttle launch or something like that, you know, and do you think it'll get back to that kind of anticipation, or we kind of like it is now, we have these research projects, hey, they're sending the satellite, or doing something in the International Space Station, or kind of like these kind of one-off projects by itself?
I think there's a definite possibility with this happening because it's a great question because role of NASA is pretty influential in shaping not just the United States' view of the exploration of space, but the world in general. So it does play a very vital role. As for the media's the coverage, one of the things I can definitely say that I believe moment we again start sending people up to Moon or to Mars, it will again capture the imagination of just not the United States, I would think the entire world, because human exploration is the most, I would say, the most fascinating and the most exciting thing that one can dream of or like to see, because as an astronomer or even I would say my fellow Science Nights, I think most of us, and on a more serious note, many of us didn't necessarily become astronomers, but did become scientists because of NASA's influence on us, and sending this idea of sending human beings into space, because we have always read science fiction stories of human exploration in space and all those traveling through space. So I think sending humans onto Mars or to Moon to explore the new grounds, I think would definitely change media's coverage, because because media knows that's the big selling point. Unfortunately, they're not going to cover these things as you're talking about the research projects. But I wouldn't say these research projects are not needed, because to send right now, for example, to send human beings to Mars, we would have to first set things up. So I would think if there's a definite plan for us to send human beings to Mars, you would have we would start sending satellites up to Mars with supplies which would contain essentials to set a base up. So I would think moment that starts happening, I would think that immediately the interest in NASA would pick up. And after one or two successful missions of just sending materials up to space, I would think we would start to get the money rolling in again, just like with things. So, but I guess Sean and Thomas can also talk about how they were influenced by NASA, and would NASA have the same influence right now for a child growing up? So.
Yeah, it's an interesting question. Really great question to our listener. I really like this one a lot, and it's interesting because it's more expensive to send people into outer space. Everything gets more expensive. There's more equipment involved. It's everything's heavy. That all the food and all the equipment and everything to support humans. Everything gets more expensive. The price tag gets more expensive. But like Anirban was saying, I think that the attention that it would get would basically make it worth it, right? It would end up paying for itself. And I'm such a nerd that I love the coverage, what little coverage there is of these probes that they send. When they land on Titan, a moon of Saturn, when the most recent probe that did a flyby of Pluto, I was glued to the screen. I couldn't believe it. It's just so cool. But I'm not your typical, 10th grader or something like that. I'm not even, a typical adult, I suppose. So it's exciting for me, but it takes a little bit more, I think, to get the general public involved. And I think you're right. I think they need to send people.
Yeah, and this is, I think we've talked about this before on a previous show, about kind of the cultural aspects of the questions. Does our culture here in the United States, does it have the same drive, the same curiosity that the culture had back when we first sent people to the moon? And is that what it takes to have it happen again? I think another thing that people need to keep their eye on, and I think people are the private companies who are starting to explore aerospace. Whether or not they'll be the first to get to Mars, I don't know. It's probably going to be NASA. But I know, at least for me, I was kind of the first generation of kids who were told that we were going to be on Mars when I reached adulthood.
Yeah.
So I always had grand dreams of being on the Mars mission myself when I was a little middle school.
Yeah, it's funny. We belong to a kind of a strange generation because the three of us were inspired by NASA, yet we belong to that generation that saw space shuttles blowing up. Right. One of my earliest memories was, the one in '86. I think it's the anniversary today. I think, or yesterday. And that kind of was. It really threw NASA off for years. No one even knew if they were going to fly another shuttle mission. They were like, "This is too risky." But we've now kind of recovered from that. I think we're now in a generation where everybody knows what the risks are. A lot better than they did, back in the 60s. Like, we've seen enough of these calamities that I think people know that, and they're still willing to support it.
And I would like to also point out that that even though in 1980s when we had the disaster, we forget in 1950s and 60s we had many more people dying. The test pilots who were testing those high altitude planes, they were dying.
And 3 astronauts did die on the platform. Yeah.
And there were people who were dying, and there are lots of more deaths before we came. And this is just like human beings, like on Kon-Tiki, setting out. Like you are going to find new some people are brave enough who venture out. I mean, I'm not saying I'm a person who would be able to get on a small raft and venture out in this wide open oceans. I'm not that person, but there were people who did that, and we are here because of those people.
So if NASA came knocking on your door, Dr. Bhattacharjee, and said, "You got a ticket to Mars. Are you going?"
I would think that's a definite yes.
Are you going to ask whether it's a one-way ticket or not?
That's okay.
That's where I think, when you mention the private companies, I think you're onto something there, because they're going to find motivated people who, they're not going to have to go through a rigorous process of selection like NASA would have. These people aren't going to be athletes necessarily. They're not going to be the best fighter pilots in the world. I think their selection process is going to be, how much money do you have? And they're not going to guarantee safety or success. They're just going to take people who are willing to pay $650,000 to live on a spaceship for 3 years and not necessarily come home. And I think that may be how we get there first. And that's kind of the way it was, the exploration of the Western Hemisphere. It was all private enterprise, and it was very risky. And ships went down all the time, and they would get to the New World, and all 400 colonists would die. That's in our DNA too. That's in our nature to explore, is also to put up with that kind of thing.
I mean, you can just not take. I'm not talking. You can take this exploration gene and take it back, way back, even more when the first humans showed up in United States, like 15,000 years ago, when there was a land bridge across Bering Strait. Like, why did they come? Like, all the way up there, like freezing.
Maybe the mammoths are a little bit tastier over there than here.
In the freezing Siberian tundra up there, like little.
Yeah, I don't think there necessarily has to be any sort of drive other than just the seeking new places.
Yeah.
And
I'm certain they could find plenty of volunteers. And, it's funny, when I was a kid, like you were talking about, Thomas, I wanted to be that, oh man, if I could be an astronaut and explore Mars, go fossil hunting on Mars. Now I don't want to go. I don't want to go at all. I would be very curious about who went, and I'd want to follow them, and I'd be rooting for them. But you couldn't pay me enough to get on that ship. I like the Earth just fine.
I mean, I'm pretty sure having a kid also changes.
Having a kid is a big thing.
Yes.
But still, I've really fallen in love with planet Earth.
Yeah, as I said, like, I wouldn't, as you said, would somebody give you a ticket? Yes, of course I would. Like, at this point, I would say yes. But, so I think sending human beings up, even to Moon, I think would be a great idea. Setting up a base.
Yeah.
Like a permanent base up in Moon, which could have just like we have on a space station, where human beings go and come back, would be a great.
They make a good point about it, because when I first heard about, like, various administrations in the past have talked about getting NASA kind of up and going again, they always talk about, we'll go to the Moon first again, we'll go back to the Moon, and I've always thought, no, we've been there and there's nothing there. But then they've made a good case for it now. They're like, there's water ice on the Moon. There's stuff that you can make fuels from. I mean, they could probably find some pretty awesome rare earth minerals to make it worthwhile, like in terms of cost. So, actually, it makes a lot of sense now to go back to the Moon first. Set up a base, get some ice, get some fuels, get the hydrogen out of the ice to fuel the rocket. I mean, it didn't make sense to me at first.
Yeah. You know what? That kind of transitions into our next question, but we're going to get to that after the break. We have some time left to expand on John's question, so go ahead.
Well, I was just going to say that the three of us were scientists, and we kind of think of it from a scientific perspective. But if you look back in history when we first landed on the Moon, what that did for us as a country, just our society and national pride, and not just national pride, but kind of a pride in our species.
That was kind of to me. That was, and I think everyone kind of recognizes that it wasn't nobody. I mean, we got there, but the whole world was rooting for us. I mean, it was an achievement of the world. It really was.
Yeah, and we look at our current climate in terms of division between groups of people in our country, and it's like something like that would be great things. I think it brings people together under one cause, one great achievement, and even if it's landing on the Moon again, to have a whole generation that gets to witness that again, and we accomplish this, and if it is leading us to ultimately going to Mars, it's even better.
Yeah, I think that's the way to sell it too. We're not going back to the Moon to collect, rare earth minerals to come back to build more microchips, which, private enterprise, it might be the way they do it, but no, this is just a stepping stone to get to Mars.
And I was going to say, like, one great thing about NASA, even though it's completely, it's where Americans are who work on it, and it's funded by Americans and everything. Like, it's very interesting when I was growing up, like, and talking from my some of my friends. NASA has this appeal to the entire world where you feel like NASA just spiritually is not just the United States. It's like as if like it is for the entire world. Like whatever NASA does, it is for the entire world and not just for the United States. Yeah. So when you send somebody up that was basically entire human beings as a species evolving from evolving from just being on Earth to somewhere else. So I would think that's one point, like more emotional kind of thing about NASA. And the second thing that I would like to point out about having a moon base is good because moon is launching things from moon is way easier than launching things from Earth.
Yeah.
So there is its gravity is much lower, so you can much less fuel will be needed to just send stuff up from there. So and moon has a lot of tunnels, and where you can immediately you get shielded from solar radiation.
Wait, it's got tunnels? Well, how do we know that?
Oh, we already did the radar measurements, and we have sent, so we already know there are tunnels up.
It's geology. We know it because of geology.
Okay,
so there you go.
So these aren't, if you're picturing tunnels that people made or that some critter made, these are like some sort of volcanic
something
tube,
like
a lava tube?
Lava tube kind of thing. So some of the lava tubes might be sealed, might have...
That would be convenient, wouldn't it?
So,
yeah. Burrow, basically. Get out of all that harmful...
Radiation, you don't even need to build like a dome-type shelter kind of thing. You can just go there, seal it up.
Wouldn't that be funny? Like, if we end up going on the moon and colonizing it, and then we become cavemen. Right? It'd be a hell of a lot cheaper than building some big structure.
I mean, if somebody... for example, like, I can pretty much... If you are growing up in moon, right? And if you've spent your entire life in moon, you won't need to exert so much force, and your muscles will not need to be as strong as they are, or your bones don't need to be as strong as they are on Earth, because Earth has atmosphere and moon doesn't. So physiologically, you're going to have certain changes, and I assume if you keep on living over and over again, you will have a totally different species of human. Eventually. Yeah. And who will actually most probably need pressurized suits when they come to Earth. Just to
oh, wow.
Because it would act as if, like on Earth, it would, to them, it would be like as if you're diving deep in the seas, like you need really pressurized suits, right? Like you can have the deep sea diving to prevent the pressure from collapsing on them. So, so that...
What would we call these people?
Moonies,
Loonies, Lunars,
but moon people, I get, and we can say they have the moonshine in them, on them. So, John, did you have any other question? Did you have anything other to ask us? I hope
that was it. That was just my original question. Thank you for the answers. It was very informative.
Thank you for being our very first caller, John. You're going down in Science Nights in the Morning history. Thank you so much for the call.
And thank you for listening to us.
Yeah, I try to catch as much as I can. But yeah, I've been in astronomy, with science and for years and years. I mean, even my older sister back east, she had to do the famous planet project, where you each planet you hang in with a little mobile system,
Are you talking about like a scales kind of thing where you have the scales of like how big the planets are and how distances are?
Like kind of like a little, like for like a science project, like your basic science project.
Yeah.
Make little snow globes and all that. Put paper mache and put it together. Makes your planets. It's cool.
Yeah, and then like yellow was the sun.
Hit it with a stick. Is that not? No. Okay.
Thanks again for calling, John.
Thank you again very much for calling, loyal listener, John Harlow. Thank you so much.
And have a good day.
You have a great day. All right, so we're going to take our commercial break right now, and we're going to get back with another question that kind of leads into what John's question was.
Outstanding.
Which is really, what formed the moon, and did the meteor that kind of ended the Ice Age, the Snowball Earth, affect the moon as we know it right now? So we will expand on this after a quick commercial break.
The moon.
All right, and we are back with the Science Nights. We want to thank John Harlow for his very, very well-versed question.
Great question.
Yeah, it's a great question. And we have another good question on the way. This is from Tom Razor. My dad actually asked this question. But we have a lot from other listeners, too. But this actually goes perfectly with John Harlow's question. He was asking about the Snowball Earth hypothesis, and also what exactly is made from the moon. Is it made from the Earth, or how is the moon?
What is the
actually,
moon? Is that the
what is the
question?
moon?
Yeah,
right?
What is the moon?
So
What
I'm
is it?
sure you can expand on this.
That's an easy one.
Here.
Yeah, I love that. And, I don't know much about it, but Anirban, why don't you get us started on that one?
Oh, started about, like, what is the
Yeah,
moon?
well, what's the moon? Well, okay, maybe we'll do it this way. There's kind of competing hypotheses about what the moon could be. And that's a good thing for the listeners to our listeners to know that science isn't us just telling you the way it is, but often there are kind of two competing hypotheses or two, like, models for how the moon was formed, right?
Yes. I mean, one of the easiest thing is for us to visualize is when Earth was forming, it was similarly big enough another structure, like a rock or something that was going around, and which essentially became the moon, and then there was Earth. So pretty straightforward.
two separate balls of
rocks, like
molten stuff, and they just happen to be next to each other.
And Earth being the heavier one kept the moon in its orbit, basically, and the moon started going around it. It's two different things. So one of
the other possibility
is
more dramatic one, right?
More dramatic one, and it's dramatic one, but it has its own kind of like merits to it.
Yeah,
that's what I was looking to. The idea. The idea was as the Earth was forming 4.5 billion years ago, it was still not Earth as we know it. It was still proto-Earth, we can say. There was this huge object called Theia which collided with Earth, and a part of Earth got ejected out, and part of Theia got ejected, broken up, and mixed with that part of Earth that got ejected out and formed the moon, and part of Theia got left behind on Earth, and as you know, we became Earth. So this is called the giant impact theory for formation of Earth. So there is that theory.
And so those two competing hypotheses have kind of you end up with two. There's completely different data you could get to support one or the other.
I mean, one of the easiest one is like the first one is the easiest one when normally how you see like planets formation happens. You will have a satellite formation happening like just around it. It's like normal what you will have like how planets form. We talked about in an older older episode where we talked about planet formation was basically
in terms of what kind of how would you test it? We've gone to the moon, we've picked up rocks on the moon, and we can analyze them. So what would the prediction be if it's just a ball that's been hovering around the Earth, no collision? What should that material be? Versus if it was a collision, what should that material be? So that's what it boils down to.
Yeah,
right?
Basically that's what it boils down to. But unfortunately, what we can the problem is like you have to remember, like if there is like what's happening. As you go away from the sun, the temperature starts dropping, right? Depending on if you're really close to the sun, you're going to be hot.
Mm-hmm.
So everything's going to be molten. It doesn't matter what it is. So your temperature is going to be molten. As you start going away, the temperature starts dropping. So at different temperatures, different things start solidifying.
Yep.
Right? So you all know that. So at a certain temperature range for our Earth when it started forming, certain materials would be cooling down. So you would have a lot of those materials at that point, right? So basically using that, you can already assume that both the moon and Earth, if they were forming at the same positions, they would essentially have similar materials.
Yeah.
So obviously that gives us immediately, so it's very hard for us to discount both the theories.
I was going to say, like, I set it up for the listener to kind of hear like how we would try to figure this out. And we've collected rocks, and one of the things I know already about the rocks that we've collected from the moon is that they're really old. They're as old as a lot of the asteroids that hit the Earth, and those all happen to be around the same age, around the what we assume is the time that the
oldest rocks
the solar
on Earth,
system formed. Right?
Yeah.
And you can hardly find those sort of old rocks on Earth because they've been melted and reformed, and they got different dates. But the raw material out in the solar system, super old, 4.5, 4.6 billion years. And so if you find rocks on the moon that are that old, then that means they're as old as the solar system, which doesn't help you distinguish whether or not it was because of an impact or not.
Exactly. But what we have, first of all, both moon and Earth, they are spinning pretty much in the same orientation. Like they are spinning in the same plane kind of thing, the orientation they're spinning. So that's one of the things.
Although the moon's stuck and it's not, rotating, right?
No, moon is rotating. It's just
it's rotating at the same.
No, moon takes 28 days to go around the Earth once, and it takes the same time for it to rotate once. So one lunar day, so a day on moon is going to equal to its 1 year, a lunar year. A lunar year is 28 days, and a lunar day is 28 days.
Okay.
Does that make sense?
Yeah, but why do we only see one face of it?
Oh, so what is this called? Something called the tidal locking. It happens when you.
That's what I was talking about.
So this is called a synchronous rotation.
Yeah.
So when your time it takes to rotate is equal to time that you take to revolve the full.
Yeah.
path.
Okay. So it just seems to us like okay.
So we always see the same face.
Yeah.
And it appears to us as if the moon.
And that means it's super synchronized.
Yeah, with Earth.
Yeah.
And this is something which will happen to Earth if Earth exists around 5 billion years from now. This is going to happen to Venus, and already Mars and Venus are very close to getting aligned to the Sun's. So since they're closer to Sun, their time it takes for them to go around the Sun once is going to become equal to 1 day on Venus or Mercury. So.
What about the material that they did collect on the moon? A lot of it is geologically. Thomas, you want to chime in here? It's a lot of like the stuff that's found really deep in the earth.
Well, not necessarily really deep. So the moon, at least the outer part of the moon, is basalt. Basalt is a rock that we can see around here in West Texas. It's a really dense rock that's made up of iron-bearing minerals, and it's the first rock that would have formed on the early Earth. So way back in the Hadean, which is the period of Earth's history where it was basically an inhospitable molten blob, basically. The first rocks that started to form at those high temperatures are the rocks that formed outside of the moon, which is really neat to imagine because today we have basically two kind of major groups of rocks, compositionally speaking, that make up our crust here on Earth. We have the basalts, mafic rocks as they're called, compositional terms, that make up the oceanic crust, so the stuff that's beneath the ocean, and the continental crust, which is mostly granitic rocks. So it's made up of silica-bearing minerals that have a lot of silica. In the earliest stages of Earth, what we see on the moon is it's entirely basalt. It's entirely mafic. So these early formed minerals, these iron-bearing minerals, formed at very high temperatures. And they would have formed our original continental bodies. And it's through plate tectonics, the earliest movement of the lithosphere, that a mixing and isolation of these less dense silica-bearing minerals that eventually led us to our continental crust. That didn't happen on the moon. The moon is covered in basaltic lava flows. We were talking about the tunnels. Those are lava tubes that we can see sometimes collapsed on the surface. So, compositionally speaking, there are similarities there.
And another thing, one of the things they talk about, if Moon and Earth were formed as two separate bodies, Moon would have a bigger iron core. So, which it does. The Moon has a very small iron core, which means what they're saying is during the impact, this object here, when they collided, had an iron core and deposited most of the iron core onto the Earth, and it sank inside. So Earth in itself has a bigger iron core compared to any other planet.
iron nickel core, so our much greater one,
Which gives us our
magnetic field,
Yeah, that's good.
and then
That's good
moon on the other hand compared to
Imagine that if this impact gave us the kind of iron that we needed to have this magnetic field, which makes life on Earth possible. How cool is that? What was the name of this hypothetical?
Thea.
Thea? Isn't there one called that that's out in the... Have I heard that before? What does that mean? You know what
I mean,
is that
Thea
like
is just a
goddess or something like
Greek
that?
goddess, basically. I think it's something to do with Pluto, I would believe. I'm just
Anyway, it almost sounds like it could be like a real, like a planet or a moon or something like that, because it's got one of those cool Greek names.
Oh, so it's Thea is a Greek titan, one of those,
one of the
and
titans.
she was the mother of Selene, which is the old Greek name for moon.
Oh, cool.
So yeah.
Okay. Neat.
So I just looked it up.
Pretty good. Well, thanks for telling me.
Yeah. So so we have that.
That's cool. I like that evidence that the moon overall is lighter than it should be. It doesn't have this
like the iron
core that it would have if it had just kind of cooled and spun in place.
And Earth is a comparative to other Mars and Mercury and everything. It has a much bigger
so
iron
it's
core.
kind of asymmetrical.
Kind of that
between
way.
the two of them.
But the problem with that is moon has water and it's trapped in there. So, but the question now comes in, like, such an impact would not allow the water to exist in the south pole, right? If I'm not mistaken, like, would moon have...
would it just evaporate on impact or something like that, such a small body?
Yes, that's what one of the things are. So, and also, I think... so there are a couple of issues. It doesn't
surely you could have some pockets of water that would survive somewhere and maybe could still get to the surface somehow. I could imagine that. Yeah. Or what if it happened when the Earth actually already had oceans?
I think
would
that's
it become
way too
remolten?
No.
Yeah, this would have been before there were any
oceans.
Okay, long time ago then.
Way before.
The Earth wasn't a very nice place for the first few million years that existed.
Okay, so I think we
looked like
we
Mordor.
covered where the moon possibly, but yeah. So now we're talking about the early Earth. We can kind of shift to the other part of this question, which is involving Snowball Earth, which is a hypothesis out there. And Thomas, you know this more than I do. What's that all about?
Well, basically, throughout Earth's history, we've had major glacial episodes where we have much more continental ice that extends towards the lower latitude. Snowball Earth basically says that I think 650 million years ago, something like that, the Earth was covered in ice. Now, the reason we're calling this a hypothesis is because there is a lot of debate on whether or not Snowball Earth actually happened and whether or not it was the entire Earth covered in ice. It's not very realistic that the ice extended down to the equator, basically.
So let's bring it back 600 million years, 650 million years.
I think
like
that's
150 million years before the Cambrian explosion.
Yeah.
So this is when there would have been life on Earth, but it would mostly have been single-celled organisms.
Exactly, that's what I was getting to.
Yeah.
So for them to survive, let's say unicellular organisms to survive, would they need sunlight? So because
photosynthesis would have been going on for a couple of billion years.
No,
already.
no, I'm sorry, I'm just
by a single-celled like cyanobacteria.
No, because my question is leading on. I'm interrupting here because if it's a snowball Earth,
so if there was ice over all the oceans, could you still have photosynthesis?
Yes,
not like it is now, but yes, you could have had there are photosynthetic microorganisms that can live on ice. And they'll give the ice like a pink appearance or even a green appearance. Like you can find it in Antarctica. So you can have microorganisms, and they could have done it, but you don't base a whole ecosystem on that.
And you also have to consider this is 650 million years ago. Geologically speaking, we're just a short time before things really explode, and we get huge numbers of complex multicellular organisms emerging on Earth. So to think that the entire Earth was covered in ice and that some single-celled organisms managed to stick it out to me doesn't seem too reasonable. We have, of course, have other catastrophic events. We've talked about mass extinctions in a few of our other shows, but something like that to have prolonged coverage of ice, this to me seems like it would be too devastating to.
I don't know. I think like as long as there were thermal vents down in the bottom of the ocean, that kind of thing, extremophiles. There's all. I think like you can do whatever you want to this planet, barring having the sun blow up and just completely take it out. And microorganisms are going to survive it. That's my feeling. But before, what's the evidence for this snowball? Why do they even? Why is that even the hypothesis?
So when we look at glacial periods in Earth's history, we have a number of things that we find associated with them. We have geologic evidence, or glaciers actually leave physical evidence on the surface of the Earth. They create scars, linear scars. The deposits that glaciers deposit as they're retreating are unique, different from any other environment in terms of the structure, the composition, well, not the composition, but the texture. So we have that evidence, and what that leads us to is we find evidence of that at lower latitudes, so approaching the tropics, approaching the equator.
What they think was the tropics back 650 million years ago.
Yeah,
and that's probably where the rub is, right?
Yeah.
So they think that they found some, glacial scarring of some kind, some tillites or something like that.
Yeah.
That they think were at the equator 650 million years ago, but if they're wrong, then it was just an ordinary ice age.
Yeah.
So, if I'm not mistaken, when I was I think one of the things I read about is like they're used to. I think this might be the snowballs where is like they used to have glaciers in like the Arabian desert is one of those things. Is like one of the evidences is point towards.
Yeah.
So they should have a corresponding evidence of massive glaciation in. Sub-Saharan, if that's the case, do they have that in Sub-Saharan?
They do, yeah.
Okay, so they have that, okay.
Yeah, and another thing to keep in mind, and this is a little bit off topic, but, we've talked about plate tectonics. I think we had a whole show about plate tectonics. And we've seen this sort of evidence before, much later at the end of the Permian, so 251 million years. And this is one of the earliest pieces of evidence that was actually used in what was then called continental drift hypothesis, but eventually gave us plate tectonics, was the presence of all this evidence of glaciers crossing the equator and around the tropics. Just didn't make any sense. So in that case, what it told us was that the continents were in a different place.
Yeah.
All this talk about rocks probably got you all very excited about seeing lots of different kinds of rocks. If you want to see a lot of different kinds of rocks, go to the geological trail at the Chihuahuan Desert Research Institute. You will see all different kinds of rocks, and they got the dates and everything you can see. Just take your family out to CDRI and check that place out. They support research locally. They do incredible things. It's a great place to hike. Get yourself the annual membership that you can get is super cheap, and you can go there anytime you want. So check it out, everybody.
And I would like to point out before we end the show, the Snowball Earth is this hypothesis.
We're coming back. We got plenty of time to talk.
So we can come back and talk about like
we can unpack this a little bit further. Okay. Let's go to a break and we'll come right back.
Hello, West Texas. We are all back. All the Science Nights. So we were talking before the break. We were talking about Snowball Earth. So which, according to Thomas, didn't really happen at all. It's completely illogical.
Well, I don't buy it.
Yeah, I don't think the Earth was completely covered in ice.
But a substantial portion of it was covered in ice. So let's say a substantial portion of Earth was covered in ice. How would that be different from a normal ice age? Would it be like, is it like a more severe ice age, would you say, or it like more lasted longer than a normal ice age? Would that be the case?
What's a normal ice age?
Yeah, exactly.
What's a normal ice age?
Yeah, there have been several throughout Earth's history, so it's kind of hard to say what a normal ice age is and what one isn't. But typically, when people think of ice ages, they think of the Pleistocene, the last great ice age, which started 2.5 million years ago. Sorry. Of course, happening much, much later than Snowball Earth, during a time when the continents were all in their current position they are today.
There were people around.
There were people around, mammals.
Mammals, you mean?
No,
2.5 million.
Yeah,
I would say like
yeah.
250,000 years ago. Are you
And
sure?
that was during the last ice age.
Oh,
that's how
okay,
Native
yes,
Americans
absolutely,
got here, because sea level was lower. Yeah, so
Yes,
we were
yeah.
around.
Yeah.
In fact, a lot of our evolution could have been kind of sculpted by the fact that there were big glaciers.
Yeah, I forget the climates, the global warming. People try to deny
it's important.
it.
It's important to realize that we've had this kind of the Pleistocene period is like 2 million years, right? Something like that.
Yeah.
The length of the
and there
ice
were
age.
multiple what they call glacials and interglacials,
Yeah.
where there were the sheets moved really far south and were really thick up in the northern hemisphere, and then they would retreat back and they would move back and forth, and they did that 6-7 times.
Yeah, and it happens on a
years.
smaller scale. We have glacial maxima, glacial minima.
Yeah, the fact
and
that we
interglacial
still
periods.
there's still continental glaciers, huge ones in Antarctica, and a huge continental glacier in Greenland. And there was up until pretty recently steady ice pack over the Arctic Ocean. I mean, we're kind of still in an ice age in a way. It's nothing like it was 10,000 years ago when the glaciers were 1,000, 2,000 foot thick in Wisconsin. That's extreme, but we still kind of have this ice around. There were times in Earth history when it was completely gone, where the climate, up in Alaska, right in the Cretaceous, which was quite warm, even though it was really in Alaska was pretty close to the pole even then.
In Australia,
and I would just like to point out before we go back into this thing is that ice age and people having warmer climates, you have to understand that warming took hundreds of thousands and millions of years.
You're going to hear that from people who kind of dismiss climate change because the climate's always changing. Yeah. It's like, well, this is happening over a period of like centuries versus tens of thousands of years.
So and hundreds of thousands.
If you're comfortable with that kind of change happening that quick,
so quick,
great.
Yeah.
But I'm not.
Not a century. I mean, not even a full century. Within like 50, 60 years, I would say.
That's what we're talking about.
So
it's a difference of scale.
How fast things are changing.
Yes. Yeah, Sean mentioned something that to kind of put this in perspective to our listeners. If you're familiar with the geography of the northern part of our country in North America, and you can imagine a map, we have the Great Lakes and Hudson Bay in Canada. Those are all glacial features. And they basically represent kind of the southern extent of glaciers that formed during the last ice age. Hudson Bay itself is this big depression in the earth that was generated by such a thick piece of ice, such a thick glacier overlying the crust that it caused the crust to deform, to sink down beneath it. And that's why we have Hudson Bay today and all the Great Lakes to the south of that. And one of I had the opportunity. I'm from Texas, but we don't talk about glaciers too often in Texas geology. But I had the opportunity to fly over the Great Lakes region. And in addition to these glacial lakes, one of the features we were talking about before, these big scars that are generated by glaciers growing and retreating, you see them on the landscape from an airplane, kind of indicating how recently that happened. So you see these big linear scars, and you see these giant out-of-place boulders, too.
I love those great glacial erratics. Right?
Yeah, glacial erratics.
They'll be like in some neighborhood in like Minnesota or something like that, and they'll build the street around it because it's in the middle. It's like a 2-story rock that doesn't belong anywhere near where it is, and they'll have to build a school and it'll have like this bent part because they have to build. You can't move it, and the rock is from Quebec, and it got dropped there by a big glacier. It's great. I love glacial erratics. I think they're the coolest things ever.
Which is very interesting. Like I was going to ask Thomas's question is like, so when I'm flying back from home to the United States or other way around, sometimes when you're going over Caspian Sea and all those areas, right, there have the glaciers there too, right, and you kind of have a feature of those, like this big stars, even from up in the sky. The land is kind of has a weird. Are you talking about those kind of shapes that you can see even from top? Like
I'd have to see an aerial photo. I couldn't say.
So yeah,
And so the Pleistocene glaciation was last 2 million years or so. Sometimes a lot of ice coming back and forth. Right now, we're definitely in an interglacial where the ice is nowhere near as extensive as it was. It's also important to note that all of our estimates of the climate suggest that at the end of that last ice age, with last glaciation, the temperature globally kind of stayed pretty still for about 10,000 years.
Okay.
And lately, it's not staying still. But this wasn't the only ice age. So what are some other kind of Hall of Fame ice ages from the geological record? The Permian one is a cool one.
Yeah, the Permian was a good one. The one that people point to for Snowball Earth. There have been some I wouldn't call them minor ones in the Paleozoic. And then we had a small ice age 10,000 years ago. So we've had multiple ice ages, and we see evidence of those in the rock record. Now, since we're on the topic of geology, and I mentioned before one point of evidence, we talked about kind of the physical evidence that the glaciers leave behind. I was just talking about this in lecture today in my historical geology class. The importance of glacial and interglacial periods where ice is either forming or melting. It has a lot to do with the chemistry of the oceans, but also the exchange of heat in the oceans and the circulation in the ocean. So these ice ages that occur, these periods of glaciation, can affect the biology, they can affect the chemistry of the ocean and the exchange of heat. So when you have a period of time where the Earth's temperatures are elevated and there's cold water that's being contributed to the oceans from melting glaciers, it causes circulation of the oceans, deep circulation. So you have all this cold water down in the bottom of the ocean that's being circulated up, that's bringing with it oxygen and nutrients, and it's essentially oxygenating the oceans. So this leads to proliferation of algae and plankton and stuff like that, photosynthetic organisms. So it has a global effect in terms of biology and affects the chemistry of the ocean.
One example of that where the ocean temperature can cause a local amazing effect. The cold water current that goes along the side of Peru causes this upwelling, this nutrient enrichment, which supports these massive fisheries of like anchovies. And enormous amounts of seabirds feed on those fish and sea mammals. And every 10 years or so, that current gets shut down and it becomes a warm water current from the equator and replaces that cold water current. And that's El Nino. Just that one local thing kicks off this kind of chain of events that changes global climate. So when you have that happening, imagine that's just one little place on Earth where the cold water current becomes a warm water current, and that's kind of a natural event. What happens if all of the ice sheets melt and you get all that cold water going everywhere all at once?
Yeah. I was just going to say, not just thinking of that, I was going to say, how long does these ice age typically would last for? Like, the Pleistocene one is, like, I think now, for 2.5 million years?
Yeah, a couple million years.
So usually they should last for a couple of million years, right? Or there's no fixed time scale?
There's no fixed time scale.
Okay.
Yeah, it's really hard. It would be hard to estimate. Like when the Permian one happened, the Permian is like 300. How many?
251 million
250. Years. Okay. Imagine how hard it would be to try to reconstruct the glacial episodes 250 million years ago, when we have a hard enough time trying to find out what the glacial periods were for the last one. Right?
Yeah, and to some degree, it relates to Milankovitch cycles and stuff like that, but we could talk about that on a later episode. But if we kind of bring this full circle with Snowball Earth, like Snowball Earth is a good example of a glacial period or a cold period that would have been prolonged, because all of the ice on the surface of the Earth would have reflected a lot of the sun's energy through albedo.
Exactly. Yeah.
So without the kind of elements that would reduce the growth of the ice, and with all of this energy being reflected off the surface, that allowed prolonged growth and sustaining of the ice during that period. So Earth, conditions change. The present isn't always the key to the past. We look at the Earth's history, and we have continents that have moved throughout time. We have different conditions. We have different life on Earth. So,
a really great place to ponder that Chihuahuan Desert Research Institute.
There you go.
You got to get up there. It's right off of State Road 118, just southeast of Fort Davis. And if you go and you mention that you heard about CDRI from the Science Nights, you can get a discount to get in there for a lot cheaper than you would otherwise. So check out the CDRI. Ask them about glaciers and where they keep them. And do that for us too.
They're in the freezer.
Tell us what their face looked like
And,
when you asked them that.
Like we should also thank the people who send us the questions.
Yeah,
Oh, yeah.
Thanks a lot for
I
these
think this is
questions,
gonna
guys.
be
We had
2 or
a lot
3
of fun.
episodes.
We had a lot of fun with the Snowball Earth
So
question.
keep sending us a question.
More questions?
Yeah, more questions. We'll answer your questions. Thanks a lot, guys. We'll see you next time on the Science Nights.
Thanks for listening to this episode of Science Nights in the Morning. Be sure and follow us on Patreon for exclusive gear and uncut episodes. Check out the latest science articles on our Facebook page and subscribe to us on YouTube and your favorite podcast listening app. You can also listen every Saturday at 10 a.m. Central Standard Time at BigBenRadio.com. And if you got a question, we'll join the discussion. Hit the hotline at 432-217-1983 and record your message. We couldn't do this without you, and thank you so much for listening each and every week. That's Science Nights in the Morning with a K, and we'll see you next time.